High Availability Overview. In this nugget, we're going to be reviewing your options for creating high availability with SQL Server 2008. We're going to start by stating the goals for high availability, and then we're going to look at high availability as it can be delivered by hardware, by Windows failover clustering, by database mirroring, by replication, and by log shipping. So let's start by reviewing the goals for high availability. One of the things you need to remember is that although some of the techniques for achieving high availability on SQL Server can also be used to achieve certain types of scalability benefits or performance benefits, we're talking specifically about why we might select one of them for high availability. So we need to understand what our goals are. Our goals are to have a second copy of our data. And this might be a particular database or all of our databases or whatever. And depending on the trade-offs we want to make, we might want to have real-time or near, we'll put that in parentheses, near real-time switchover. Meaning that if the primary copy of our data becomes unavailable or corrupted or something else, we want to switch over to the secondary copy as quickly as possible. We want that second copy to be updated fairly frequently, if not in real time, so that it's always up to date, so that if we lose our primary copy of our data, then the secondary copy is right there ready to take over with relatively work on our part. And that's another goal, reduce workload. Ideally, we might even want this switchover to the secondary database to be automatic. So those are some of the primary goals for high availability. Overall, what this rolls up into is less downtime for our users. Anything that achieves less downtime is part of high availability. So let's talk about some of the techniques SQL Server 2008 offers for high availability. The first one that you might think about is hardware. The second one that you might think about is failover clustering. Probably the third one that you might kind of come to in your head is replication. SQL Server 2008 also offers another technique that we'll talk about called database mirroring. And we'll also talk about why that's different from replication, because it certainly is. And then a fifth technique that you could use is called log shipping. Now in this nugget, we're going to talk about all of these and how they contribute to high availability. In Nugget 13, we're specifically going to talk about failover clusters and database mirroring, which use similar seeming techniques to get similar seeming results, and we'll talk about how to set those up and everything else. In this nugget, we are going to be setting up log shipping, but we're going to talk about all these. So right now, let's start by talking about hardware. Now this, of course, isn't something that SQL Server 2008 itself provides. This is something that you build into your hardware. Things like redundant power supplies. RAID arrays for your disks so that you're kind of protected against the failure of a single hard disk drive unit. You might have redundant CPU power supplies. You might even have something like redundant network cards. You might have redundant SCSI or SAN controllers so that the machine can't be taken off of its storage network by the failure of a single component. The idea here is basically redundancy. Double up as much of the hardware as you possibly can so that if one bit fails, then the other one can take over and the server keeps running. This is a great set of techniques to use in conjunction with a lot of the failover and clustering and mirroring and other high availability techniques that are available from within SQL Server itself. This sort of prevents those things from becoming necessary, but if they do become necessary because of a total hardware failure or a loss of power at a facility or a loss of network connectivity at a facility or some other overarching thing that you just can't build redundancy for, well, then you can rely on SQL Server's redundancy features. It's important to understand, though, that those hardware things are there because they're definitely a design consideration that you need to have in the back of your head. Now, SQL Server failover clustering is something that we've talked a little bit about before. This is built on top of the Windows cluster service. The idea is you get two nodes, node A and node B, and between them they have some sort of shared storage. They're both attached to it, and they can both technically see it, but they kind of have a gentleman's agreement to not try and touch the storage at the same time. That storage is where your data lives. Now, clients don't access these by using either server A or server B. Instead, there's sort of a virtual server name that exists. We'll call it nodes. Clients connect to that. And then whichever of these nodes is active at the time is the one that actually responds to those client requests. And that's the one that actually sees our data and is able to access it. If something happens to that instance, then it stops working. The second instance, which is constantly trying to communicate it to see if it's still up, says, oh, hey, it's not working anymore. I'm going to take over. It's no longer going to see the storage. It's no longer going to respond to client requests. I will look at the storage. I'm going to start up a copy of SQL Server to look at that database, and I will start responding to client requests. Now, that's kind of a simplified look at the way Windows clustering works, and we are going to go into it in more detail in Nugget 13. So the idea here is that these individual servers themselves can have a lot of hardware redundancy built in, redundant power supplies, whatever other redundancy you're building into your hardware. But in the event of a total failure, there's a second node standing by ready to take over. Now, what I just described is what's called an active-passive configuration, meaning that one node is active all the time, and the other node just sort of sits there and waits for the first node to fail, sort of like the vice president. Doesn't really have a big job to do. In SQL Server, you can actually build active-active configurations. In this case, you might have another area of storage with another database on it, and another virtual, and we'll call this nodes 2, virtual server name, so that client requests coming into that are piped over to this node, which is active and sees this storage and uses this database. In the event of a failure, say of our other node over here, server A can take over for both of these. And it might not run as well, running both database jobs, but it's better than one of them being offline completely. That's also a nice maintenance thing. And one of the reasons you might select failover clustering for SQL is because you know you're going to have to be doing maintenance to these servers. So you can manually have node A take over both databases, do whatever maintenance you need to do on B. Then you can manually move both instances over from A to B. And then while B is running both of them, you can do your maintenance on A. So that's a really nice technique. SQL Server supports multiple instances that way too. We can have nodes A, B, C, and D. And node A might be running SQL Server 1, SQL Server 2. Node B might be running SQL Instance 3. Node C might be running SQL 4 and SQL 5. And node D might be running SQL 6 and SQL 7. If node D for some reason goes offline, we might have things configured so that SQL 6 moves over to A and SQL 7 moves over to B by default. And that way you've got a lot of database instances running, and they've all got multiple places where they could live. That actual failover time really only takes about 20 to 30 seconds, depending on exactly how things are set up. Typically, if a client is trying to talk to a node that has just recently failed, it might time out, but usually it'll retry a couple times, and by the time it all finishes failing over to its new home, the client will have been able to get in touch with the new home. It will have retried and it won't time out. So clients usually won't notice anything. So those are the reasons that you might use failover clustering. Now next is database mirroring. Let's say we've got two SQL Server instances, A and B. SQL Server A has got two databases. Normally these would be located on different servers, by the way, these two instances, although SQL Server doesn't enforce that. It just needs them to be two different instances. So let's say SQL Server A has two databases, 1 and 2. We are going to create a copy of database 1 on SQL Server B, and each time a new transaction or a new change occurs on A to its database, it's going to send that transaction over to B, where the same transaction will be performed, bringing database 1 up to date, so that the two are essentially mirrors of one another. Clients out here in the network have to use some special software. They have to use the most recent SQL Server native client so that they can connect to this mirrored session. And it's up to the client to realize that A is unavailable if it becomes unavailable, and it's up to the client to then go over to the mirror partner, or B. So it requires a little bit more being careful on the client side than failover clustering. In failover clustering, all of this switchover business is completely handled at the server, and it's transparent to the client. Now, there are several different modes for SQL Server mirroring, and we are going to cover those more in Nugget 13. However, you do need to know that if you decide to select mirroring, that it does occur on a per database basis. With failover clustering, it's a per instance thing. Every database handled by an instance is automatically dealt with that instance. With mirroring, you have to configure mirroring on a per database basis, and there is some interaction with other database engine features like log shipping, full text catalogs, database snapshots, and replication. These features all involve forms of storage outside of the database itself, and mirroring definitely has some interesting ways that it works with these. It does work with log shipping, it does work with full text catalogs, it does work with snapshots, it does work with replication, but you need to be aware of some of the interactions that go on there. One last important thing to remember about database mirroring is that it does not support the file stream data type. So if you have databases that are using file stream, then database mirroring is not an option for you. The next high availability option is replication. There are 3 different types of replication within SQL Server 2008: transactional replication, merge replication, and snapshot replication. Snapshot replication is literally designed to take a copy of a database or recent changes to the database and push those out to subscribers. Those subscribers then wind up having an identical copy of the data. Merge replication is designed to have several different copies of a database all being updated by different users and having all those updates sort of come together and merge, not unlike Active Directory replication. Transactional replication is designed to take individual changes that occur to a database, push those changes out to subscribers, which use those changes to update their copies of the database almost in real time. You can see how each of these would be able to contribute to a level of high availability. You do get a couple of sort of caveats around these guys, though. For one, there's no built-in type of failover. Let's say I've got a SQL Server database A, and I've got another SQL Server B, and another SQL Server C. And let's say that most of my clients are connecting to C to make their updates, and it's using replication to push those updates out to A and B. Well, if for some reason server C fails, replication is not going to automatically redirect clients to A or B. Instead, the clients would have to be programmed, the application they're running would have to be programmed to do that on their own. So from that level, the very best you're really going to get from replication is sort of a real-time or near real-time type of automated backup, if you will, so that if server C goes, you've got a copy of your database over here and over here. But high availability alone is not really why you would do replication. Let's take this example again where we've got 3 database servers, A, B, and C, and they all start with an identical copy of our database, and they're all in a different city. Let's say this one's in New York City, this one is in Paris, and this one is in Tokyo. And our users in each of those countries all connect directly to the server and use the database that's in their country. And they're all making changes to it. And we've set up merge replication so that all those changes get distributed and merged between all 3 of them so that all 3 have an updated copy of the database. So what we've gotten here is sort of a level of scalability. We've gotten local connectivity or more local connectivity for our users. We have 3 times as many users as we might have jumping onto a single server, so we've scaled this out to be a larger application, and we're using merge replication to make sure that the data goes from place to place. If server A crashes, the New York City users are going to be inconvenienced but not out of luck. They might connect to the Paris server or the Tokyo server, which should have updated copies of all the data. It's not as convenient for them, and it might be slower for them, but this is the way that replication is really designed to provide high availability. It's not necessarily something that you would choose if high availability was your only goal. These different forms of replication have other things, and they can provide high availability kind of as a side benefit of those other things that they do. Now, we are going to be talking about replication and the 3 different types and how to set it up in more detail in nugget number 20. Now, our last option is log shipping. With log shipping, again, I'm going to have 2 different SQL Server instances, and this instance A might have a couple of databases, and I have to configure log shipping on a per database basis. I need to get it started by making sure, again, that both instances have an identical copy of the database to begin with. In log shipping, this server is periodically going to make a backup of its transaction log. This server is going to copy that transaction log over here and then use it to bring its copy of the database up to date. The difference between transaction log shipping and database mirroring is that database mirroring happens in real time. Transactions are being sent one at a time from server A to server B. So server B's database is probably going to be very up to date at all times. With log shipping, this occurs on a scheduled basis. It might be every hour, every 72 hours. You get to decide. But the point is that database B might be out of date by up to that long of a period. So this isn't something you're going to do if you need real time. However, it is a little bit less effort on the servers. Another thing that's interesting is that log shipping doesn't provide any kind of built-in failover. If server A bites the dust, it's my responsibility to get clients redirected over to B, or use B's copy of the database to bring server A back online. You can kind of think of log shipping not so much as a real-time form of replication, but rather as an automated hot standby process. One last cool feature about log shipping, it supports the file stream data type. So if you are using a database that has the file stream data type enabled and you're using the file stream data type, then log shipping is a better choice than database mirroring, which does not support file stream. So let's set up log shipping. Now, as you can see here, I've got Nuggets 1, which is an instance of SQL Server 2008 running on this computer. I have a second instance, Nuggets 1 App 1, which is also running on this computer. And in a lab environment, this is a great way to explore log shipping. In a production environment, my second instance would probably be running on a second server, my backup server, if you will. I've started by copying my database to the second instance, so that they're starting with an identical copy. Now I'm going to go into the properties for this, and I'm going to configure transaction log shipping. And the first thing I have to do, by the way, before I even dive into that, is go to my local disk on the source machine, and I've created a folder called Backups. Let's take a look at the security on this folder. It is shared as a network drive, and I've set everyone group to have full control. Now, in reality, what's going to happen is you're going to have 2 copies of SQL Server Agent trying to get to this folder. The source database is going to use SQL Server Agent to write transaction log backups to this folder. So whatever account that SQL Server Agent is running as needs to have read-write permissions to this folder. The second instance of SQL Server Agent is running on the destination machine, and it's going to read these transaction log backups over the network using the UNC path. So it needs the appropriate permissions not only on the folder, but also on the share. In a lab environment, I've set everyone to full control just to give me a quick and easy way of getting to this. In a production environment, of course, you're going to have those SQL Server Agent services running under domain accounts, and those domain accounts are going to need the permissions here. So that folder is set up. So I'm going to enable this as a primary database, and I need to tell it how to get here. So this is nuggets1 backups, and that is in the local folder C backups. And I'm fine with that schedule, although I could change the transaction log shipping schedule if I wanted to. So let's just hit enter to take that. Now I need to identify the secondary databases, the places where this log will be shipped. So I'm going to connect to nuggets1 app1, and the secondary database is my database. Now you can enter a new database here if you want to, but since this one's already there, I'm good. The first thing I need to do is initialize the secondary database. I have to restore a full backup of the primary into the secondary before it can be a log shipping destination. Do I want it to do that for me? Yes. Generate a full backup of the primary database and restore it into the secondary database. Or I could say yes. Restore an existing backup that I already have. Or I can say no, I've already taken care of this manually. I've initialized it. And in fact, this is what I've already done. I detached the database from my first instance, copied the files into a different location, reattached the database to the first instance, and then attached the copy to the second instance. I literally went to Explorer and used copy and paste, so I know those database files are identical, and that's what it means by initialized. So I've figured that out. Copy files, destination folder for copy files. Let's create a new folder for the transaction logs that it's going to copy. We're going to call it incoming, and we are going to need to make sure that the user account used by SQL Server agent has got full permissions. So I'm going to sort of shortcut that by just giving everyone full control for right now here in the lab. So this is going to be on C incoming. Delete the copied files after 72 hours and restore transaction log. Looks like these are all good settings. So this tab is allowing me to say files are restored from the destination folder by a SQL Server agent job. What sort of recovery mode do I want to use? Well, because this destination database is a recovery thing, I don't need it to be in recovery also. So we're going to hit OK. So now our secondary server instance is set up. I could ship the transaction log to multiple places by adding more servers, and I'll just repeat that process for each one. So now let's hit OK. Cross our fingers. It's going to have to go out and talk to both instances, get that primary backup and everything going. Looks like it all worked. And now we've got log shipping running between those two databases. Now remember that log shipping doesn't occur instantaneously. There is a delay. So if I go in here and make changes to my primary database right now, those changes are not going to immediately replicate over to my secondary database. It's going to happen on a schedule, and the intent is not so much to get the data identical in real time, but to have a backup copy of the database for redundancy purposes. So now that log shipping is set up, we can just sit back and pretty much not worry about it anymore. In this nugget, we've looked at high availability options for SQL Server 2008. We started by defining the goals for high availability, and we talked about how hardware redundancy can provide a good level of high availability. We also looked briefly at failover clustering, and we looked at database mirroring. We also looked at replication and log shipping. And you may have noticed something. We get the best replication and the best failover capabilities and the most transparencies to the client at the top of this list. We get the least complexity and the lowest requirements at the bottom of the list. So that's why there are so many different options. Having very redundant hardware is expensive. Having failover clustering is expensive because you have to have at least 2 servers. Having database mirroring does impose a certain amount of load on servers, as does replication. Log shipping is extremely inexpensive, easy to set up, and doesn't really impose much overhead on the server, but it provides the lowest or the highest latency, the least real-timedness. So our backup, our hot server, our hot spare, is the most likely to be a little bit out of date when we need it. So the higher up in this stack you go, the better and the more transparent and the more up-to-date. The lower in the stack you go, the cheaper, the less complex, and the lower the overhead. I hope this has been informative for you, and I'd like to thank you for viewing.